Hello to everyone and welcome to the second webinar of the Space for Critical Infrastructure series. This webinar aims at raising awareness about the use of space to better monitor and safeguard critical infrastructures in different domains. My name is Margarita Chrysaki. I'm the Communication and Project Officer for Nereus, and today I will moderate this workshop, which is organized jointly by Nereus and EURISI. Nereus stands for the Network of European Regions using space technologies, and its main mission is to explore and promote the benefits of space technologies for European regions and, of course, represent their interests towards the European space community. As part of this initiative, Nereus cooperates with EURISI, and maybe very briefly, Cornel, if you could share with us a few words about you and EURISI before we dive into the discussion.
Yes, of course. Thank you very much, Margarita. Indeed, my name is Cornel Borgaert, and I'm working for EURISI. EURISI is a non-profit association working on behalf of more than 15 space agencies and innovation clusters. And we try to facilitate the exchange of knowledge and experience between different, public authorities, but also researchers and companies. And we do this to raise awareness of satellite applications in numerous sectors. But of course, today we are here to discuss the potential benefits of space assets to monitor critical infrastructure, especially to monitor bridges. And so this is part of the introductory sessions of Space for Critical Infrastructure. And of course, I will be managing also a bit the chat today. So I invite everyone to use the chat to write down any questions they might have, because today is really a platform for you to learn about the potential benefits of space for critical infrastructure. So.
Thank you, Cornel. I will also mention a few things about the webinar today. Thank you very much. So as Cornel said, it would be about to discuss concrete measures and practices with a special emphasis on operational satellite services to support relevant entities with the maintenance of, regarding the maintenance of bridges and the management of roads, a crucial matter for all European regions. Of course, if you have any questions, you can mention them in the chat, and then we can take over and pose these questions to the speakers. If Mr. Campora is connected, we could start with him. I don't see him. Yes, hello. He's connected. Hello, Mr. Campora. Thank you very much. So just a brief introduction. The case of the collapse of the Morandi bridge in Genoa in Italy in 2018 opened up the discussion on how space data can provide solutions to such incidents. So it is my pleasure today to introduce to you Mr. Matteo Campora, the Councillor for Transport, Mobility and Environment for the Genoa municipality. Please, Mr. Campora, the stage is yours.
Hello, everyone. It's a pleasure to participate in this webinar with a testimony relating to one of the most tragic events that occurred in my city and that shook the world in 2018, before the pandemic or the current conflict situation in Eurasia. As a Deputy Councillor for the Environment, Ecological Transition, Sustainable Mobility, Circular Waste Management, on the mandate of our Major Marco Bucci, I can try to convey the meaning of the collapse of the Morandi Bridge for a local context in its most different implications, illustrating how this event has radically changed our approach to innovative infrastructure design, more resilient and adaptive than in the past, and how it has favored the use of smart technologies as enabling factors. The Morandi Bridge, despite being a critical infrastructure, has always been seen as a companion for the daily transit of goods and people, not limited to users outside the city, but used for most of the time by citizens for east-west travel. The whole area of the northwest of Italy has grown for more than 40 years with a profile of our bridge, Morandi Bridge, as a skyline over the Polcevera Valley. The collapse of this highway infrastructure, which was on the center of our municipality, divided Genoa in two parts, caused the loss of 43 lives, literally destroyed an entire neighborhood, caused cascading economic damages, and spread like concentric circle throughout our nation in the southern Europe, on the various sectors linked to the logistic of large and small distribution on port traffic by road and railways, preventing the accessibility of the places to inhabitants, workers, and tourists on the roads affected by this collapse. In technical jargon, it was an impressive shock event, resulting in long stress despite the fact that we inaugurated the San Giorgio Bridge, the new bridge, in just 2 years, a large infrastructure built in record time, a very record time. We learned that the resilience of critical infrastructure, as addressed by the Sendai framework, comply a series of multi-level responsibilities, different impact assessment to be considered when we plan urban development under risk condition, especially to reduce and expose the various assets not being able to act directly on the possible persistent hazard in area by the man-made or natural. As a city, we have therefore enforced the term resilience and applied it concretely in urban strategies. Downstream of the collapse of the Morandi Bridge, in fact, we have set up a special office that talks on these issues in collaboration with the commission structure and the various departments of the municipality to approve in 2019 a sustainable and resilient development strategy called Genova Lighthouse. It pointed out the accent on three strategic axes, namely grey, green, and soft, that have become the design cornerstone of the city in its various implementations. The grey axis, for example, deals with implementing innovative models and design to support physical and connection infrastructure, favoring the use of enabling technologies in monitoring the territory, for example, exploiting satellite data to identify landslides around the area of the San Giorgio Bridge, evaluating the oscillation of the same in synergy with the battery of the IoT sensor located on the bridge itself. Other examples of the use of satellite data are present in the project contained in Action Plan 2050, such as the risk assessment linked to the degradation of UNESCO heritage due to the effect of climate change in synergy with pollution phenomena, or the recent protocol of intent signed with DINSAR to investigate the health of the sea in the shoreline regarding the presence of plastic, pollutant, and seasonal debris effluvium. What's really interesting is the fact that in the past this activity would have been possible to implement only through investment with European thematics funds, while today we are part of a broader plan that finds milestone in the National Strategic Space Economy Plan and in the investment of the next generation EU. I am convinced that the responsible use of enormous potential of satellite data combined with a sensor of territorial surveys can offer a meaningful knowledge basis of the fragility of the territory and allow reliable policy choices, moving from the disaster risk manager to its prevention. In this sense, the lesson we learned following the collapse of the Morandi Bridge has further strengthened our position and streamlined and operational mobility adopted by the so-called Genoa model, allowing us to understand what are the soft skills necessary to enhance our intention, indispensable for addressing an analysis of vulnerability and risk exposure of a critical city infrastructure. A further element of value that allowed us to strengthen Our territory direction was an analytic discovery of the interdependencies with the cities of Milan, Turin, and which we signed a MOU of resident city to implement shared strategies to face the risk that they interconnect us. This agreement was also used during the first years of the pandemic by implementing shared policy and implementation choice, which made it possible to share data and mutually support the territories in logistics, passing distribution, service delivery, and the use of smart technologies. Lastly, we decided to invest further with partnership collaboration as regards experiments on the use of the Galileo system to support the forthcoming critical infrastructure center. Moreover, we'll collaborate with GRC, which normally uses satellite data to implement risk analysis in our territory, applied in particular to the risk of wildfires. Undoubtedly, what happened to our city gave a robust acceleration to the use of the most modern enabling technologies to work in terms of prevention, strengthening, nowcasting with forecasting elements. Thank you.
Thank you very much, Mr. Campora, for your presentation. It's really impressive. As I was listening to your presentation, it's really impressive the series of activities you took to tackle such kind of incidents, highlighting at the same time the necessity of the use of innovative space technologies. That's quite important, and the use of different space technologies and data. You mentioned Galileo and so on. So please stay with us for the rest of the discussion with the participants. And now we are moving on to our next speaker, Mr. Giuseppe Forenza. He's a business development manager of Reticus from an Italian company, Planetech Italia, and he will explain us how space technologies can contribute to prevent such incidents, and he will share with us the example of Reticus SaveWay, a space data tool that prevents damages to roads and bridges infrastructure. Please, Mr. Forenza, the stage is yours.
Hi everyone, good morning. I'm trying to share my screen. Okay, please Margarita, confirm me. You are looking my presentation.
Everything is perfect.
Fantastic. So thank you very much. It's a pleasure for me to take part into this discussion, especially following what Mr. Campora said about the intelligence that may be involved in this process, the intelligence coming from space, that, as he said, is part of a complementary approach that involves different technologies. I'd like to connect to the previous topic addressed and to continue this exploration of this webinar, presenting like you said, Margarita, the operational services that nowadays we have in our platform Reticus, which includes a solution Reticus SaveWay, specifically tailored for this kind of complex activity, which is the predictive or proactive maintenance of the roads and bridges. And continuing what we've been discussed so far is perfectly, it's perfect to discuss now how we can move from a single bridge monitored to an entire network of roads and bridges, because this in the end is what the satellite technology today allowed us to do. What we've been doing so far is to simplify a lot this process with the Reticus platform, and in order to do that, this problem is not just a technological problem, but is also something that should be aligned with the internal process of the organization or in the operators that are maintaining this complex assets. And the topic, like you said, the point is, the goal is moving from a reactive approach to a proactive approach. How we solve this problem, and I will show you, we will dig a little bit more in the details. The presentation includes couple of words about Planetech, because what we achieved with Reticus is it was possible due to the wide and extensive experience of Planetech Italia. 28 years in the Earth observation. The company started with one mission, one focus, Earth observation and remote sensing, and we kept our mission, which is simplifying the complexity of space. So how we are trying to do that with Reticus exactly is the paradigm, data, information, and knowledge, which is the current scenario that we have on the Earth observation framework, which is the incredible amount of satellite data that every day have been acquired on the entire planet. The complexity of transforming this data into information, which is something that we've been doing for 3 decades, and the knowledge that we can now grab immediately from the satellite. And this is what Reticus is all about. Planetech operated this platform solving specific problems in specific industries like the transportation. We all know that operators are fighting against structural problems, and they are investing considerable resources to fight against land instability. Land instability or infrastructure instability may be due to natural or human-induced problem. Whatever is the problem, we all know that ground displacement is a very good indicator to realize or to immediately recognize where problems are already occurring. For 20 years, I would say, we've been using radar satellite data to analyze the millimetric movement of all the items on the ground. And most importantly, what we can have now is the analysis on the historical evolution. So we can predict long-term trends accurately. And this is bridging the gap when you have a lack of predictive information. Like Mr. Campora said, we have a lot of tools, sensors, and technologies that when installed or maintained can give us information from the moment when you install it in advance. But you need to have a big picture of the problem. And this is what we designed in Reticus Safeway. We put together the capacity of ground motion analysis that we standardize in a continuous processing and transformation of radar satellite data. We all know how complex is generating this kind of measures, but we can now understand the trends of this movement, and specifically the movements that have an impact on the infrastructures, whether they can be roads, bridges, or railways. And we can immediately pinpoint or highlight where the different level of concerns. In this case, we also have an intuitive interface that in the semaphoric color like red, green, and yellow indicates where you should prioritize your attention, where the problems reached a significant mechanical stress. So the process, like we said, how to plan and prioritize inspections. This platform is part of the complementary approach, but it gives us a very good and complete overview on the entire asset. This is the process behind the scenes, because simplifying the complexity of space means to allow the user to concentrate on the answers, not on the mechanisms. So this is the complex activity we do behind the scenes. We have a continuous collection of radar satellite data. These data are generating ground motion map. This ground motion map is matched with respect to the path of road and the presence of bridges. We have an algorithm that specifically assigns different level of and it classifies the entire road assets with respect to the magnitude and the ground motion analysis that have been performed, and these algorithms are presented in the way of list of segments of roads or bridges with different level of priority. So like when we use Google Maps, no, we concentrate our attention into the results. So the field inspections can be carried out, and you can you can pass this actionable knowledge directly to the maintenance crew. So we adopted the same approach not only on the transportation but also in other sector. Like I said, for example, buried pipelines in the utility sector are also can have this kind of services. We have reticle services specifically designed for the maintenance of buried pipelines, as well as for buildings or the entire land operated. For example, when we have a regional level or even a nationwide today, it's possible to consider this kind of monitoring activity. We can exploit this only if we can put very simple experience in front of the customer. And we created reticle services with indicators that includes historical analysis. So we, like I said, long-term trends accurately. This is our focus. And this is part of the complementary approach to prevent or try to prevent and be very proactive in the operation. Of course, we also solved a few problems about the storage of this data. Everything is on the cloud. The customer experience directly the solution in form of subscription. And the subscription includes also the update. So it can be historical knowledge together with continuous updates of these indicators over time, even when you have the post events or the maintenance is ongoing. We have, of course, different cases at different levels. Or a single bridge, or a single plan, or a single excavation tunneling activity performed by the operator. And then we have experience of working, supporting the municipality, like the Metropolitan City of Milan, which adopted Reticle Safeway for monitoring the entire network around the city of Milan, including roads and bridges. We scaled this up to the regional level. We've been working with the Regione Friuli Venezia Giulia in Italy. They're monitoring the entire region with reticles. They're receiving the analytics in forms of subscription on the land, but most importantly also on the infrastructure included and operated, which are roads, buildings, etc. So with this overview, I would like to answer your questions in case you have it. We'll be very glad, and I'll be free and available thank you.
Thank you very much, Giuseppe, for your insightful presentation. Maybe before we go into the questions from the audience, I would like to ask from Cornel to upload, to share the video on ANAS. ANAS is an Italian government-owned company that manages the maintenance of the highways and roads in Italy, activated and they activated the Copernicus-based Reticle Safeway, as Giuseppe explained before, with the objective to implement an effective road management. But of course, a video it's more attractive, so let's watch it and then we can continue our discussion.
Copernicus Sentinel data is helping the Italian roads authority ANAS design and manage Italy's highways. Transport infrastructures are key for every country. Italy's road network comprises more than 250,000 kilometers, of which over 26,000 kilometers is highways or autostrada, with many bridges and more tunnels than the whole of the rest of Europe. But Italy is also a young and dynamic country, geologically speaking, and is particularly subject to landslides and ground movements. Landslips may occur due to geological instability or events such as heavy rain or earthquakes. Avoiding or mitigating the consequences poses considerable challenges for the planning, building, and maintenance of road infrastructures. Planetech, A small Italian company offering EO services has developed a product called Reticus, after the sole pupil of Copernicus, which provides regularly updated countrywide maps of ground movements based on data from Sentinel-1. These allow millimetric movements of the ground to be detected. ANAS is now using the Reticus service to monitor some of its projects, for example, the Polizzi Tunnel in Calabria, to help understand where problems may arise and to take preventative action. As a result, the design of highways can be made more resilient against future ground movements. As roads are increasingly bearing the load for freight transport and logistics, where delivery delays can be costly. Consequently, there are strong benefits if roads are closed less often and for shorter periods, and especially keeping access open for the emergency services. Smoother road operations mean calmer journeys and less time lost for citizens and freight transportation services. Copernicus is estimated to generate potential economic benefits of between 5.6 million and 13.6 million per annum in Italy, and to help ensure that in the future, Italian highways can assure better transport services.
Margarita, can I have just one more minute for a couple of comments after this video?
Yes, very briefly, Giuseppe, and then maybe we can ask also from
Just one more minute.
Yes, of course.
One more minute, because this example of Polizzi, which is the tunneling, there is a tunneling activity in place. With the help of Reticus, we could realize what was the current situation in terms of ground movements. The historical analysis performed supported the planning operation, and now we are supporting the beginning of the excavation. And we've been keeping this monitoring, we will keep this monitoring activity in place during the entire construction phase, confirming what is starting, which are the effect of the activity in the surrounding area, and we will keep this when the tunnel will be completed. So this is the importance of satellite monitoring, and I presented the way to scale this up. And I would like to mention the importance of the Copernicus data. We maybe would be of interest to realize that Reticus was the original first assistant of Copernicus, and that this is confirming the connection between the Reticus platform and the Copernicus program, because guarantees continuous flows of information, continuous acquisition that we've been exploiting very much. Thank you.
Thank you, Giuseppe. This is very interesting what you mentioned. I would like to add here that the video is produced by the European Association of Remote Sensing Companies, ERSC. And maybe before we jump into the questions that I see in the chat, I would like to ask Mr. Geoff Sawyers, I don't know if he's with us today, to say something very briefly on the video. Otherwise, we can move on. Okay. Okay, then maybe later on.
Just a moment, please, Margarita, because
yes.
So I'm just trying to unmute Mr. Sawyers. So
Yes.
I think
yes.
He can now take the floor if he would like to do that.
Perfect. Yes, perfect. Please.
You hear me now?
Perfectly well.
Okay. Sorry, I wasn't expecting to speak, and I wasn't expecting to see the video. This is produced in the context of the Sentinel Benefits study that we are conducting for ESA, where we're looking at different uses, operational uses of Sentinel data, and the impacts they have on the users and ultimately on society. So it's a value chain approach. In the video, it flashed up 6 different benefit areas that we examine. So as well as looking at the economic benefits, we look at the environmental benefits, the benefits towards regulatory matters, whether it's decision makers or implementing legislation, entrepreneurial benefits, here Planetech are clearly benefiting, as indeed are ANAS. Scientific benefits for research, and also benefits to societal benefits. So it's quite broad, and the case in Italy is an extremely interesting one, which is getting more mature as the Retica service is used more widely, and indeed not just Reticus, but also benefits coming from the use of Sentinel-1 data. I'm interested if we're going to come back to the Morandi bridge, but maybe I can comment later on that. We did briefly touch on that in our report, but it's a very special case. Thank you.
Thank you very much, Zef. Thank you very much. I see, Giuseppe, a lot of questions for you. Is it something that you would like to reply by email? Because I see some interaction here. I see a question from
I can
the
pick a couple of
yes,
can pick couple
please make a summary, maybe a brief summary, and then we can go to Mr. Campora, because there is a question for him as well.
Very good. In the meantime, I answer. I keep my contact here, so for any of you that would like to write me, I'll be glad to answer. So regarding the technique, how we distinguish movement, as I said, we are using a technique that is called the interferometry, and this analysis allows us to produce measures on the items on the ground that are extremely stable and are considered extremely stable by the satellite. So these measures are taking into account millimetric movement, because the movement should be in a specific range. So the elasticity of infrastructure, or movements like leaves or water, or when the movement is out of a certain range, the measures are not generated. So the problem has been solved by the technique itself. Regarding the problem related to the continuous acquisition of Sentinel-1, I can say that the problem is not related to the historical analysis, because the data are being already acquired, so we can have the historical data available, and the trends can be analyzed. In future, we are expecting also to maintain the monitoring activity. At the moment, we have a less amount of weekly in Europe acquisition, but we still have a plan for continuous acquisition on a different update. Frequency, sorry.
Okay, I think you covered all questions, as I see in the chat. Maybe an important, an interesting question for Mr. Campora. It's coming from the Secretary General of EURISI, Miss Annalisa Donati. She asks, I don't know if Mr. Campora is still with us, but she asks if you can explain how the city of Genoa procures currently innovative services, as you mentioned before, to monitor ground movements, and how does the public procurement take place? So that would be a question for Mr. Campora.
I can answer by email, because I need to speak about our office, our engineers.
Mm-hmm.
I am not ready to answer now.
Okay, and perfect. So maybe another question from my side, because I'm very tempted. I would say Nereus is leading is partner to a big training education initiative, EO4Geo. And it is leading the package of communication dissemination. So it's about capacity building skills. And Mr. Campora mentioned, you mentioned in your presentation, also partly Giuseppe, about the necessity of skills. And as we know, Earth observation is a promising sector in terms of improving lives of the citizens, but it also supports job growth at the regional level. So based on your experience, I would like to ask, what are the skills do you think are needed in this domain? Mr. Campora or Giuseppe could take the floor. You can decide.
Well, I can pick the question. It's a very good question. The satellite ecosystem, I would say, has been changing. And the scenario nowadays allow us um, to realize solution like the one I presented, but for a wide adoption of this solution, it's important to be aligned with the internal process of the organization and the end user. So it's like this is like a path. So the more we are closer to the daily activity and we speak the language of the end user, and we are solving the problem of we are facilitating the adoption of this kind of solution that for many times required a background or could be exploited without a proper background or preparation in this kind of data. So the skills nowadays are in the design and in the design of the solution closer as possible to the end user problems.
Thank you very much, Giuseppe. I also put the link in the chat. Whoever is interested to learn more about capacity building skills in the Earth observation sector. And now I think we can move on to our next speakers. For the moment, we have explored how satellite data space technologies can prevent such incidents, but it would be very interesting to hear also how satellite data can support the post-management of such incidents. And the next two ladies, they have a lot of things to say about this. Ms. Simona Verde is a permanent researcher of the Institute for Electromagnetic Sensing of the Environment of the Italian National Research Council, IREA-CNR, and Ms. Manuela Bonanno is a permanent researcher of the IREA-CNR Institute as well, working in the satellite SAR interferometry field. They will share with us their knowledge on how space data can monitor the built-up environment. I will not say more. The stage is yours.
Okay, thank you, Margherita. I'm going to share my screen. Can you hear me?
Yes. Yes.
Okay. Can you see my screen?
Yes, we can see your screen. Just if you, yes, now it's perfect.
Okay, perfect. So welcome everybody to this presentation. I am Simona Verde, as Margherita said, from the Institute for Electromagnetic Sensing of the Environment, and in this of the Italian National Research Council. And in this presentation, we will talk about the multi-temporal satellite differential interferometry SAR techniques for the monitoring of the built-up environment. So satellite remote sensing plays a key role in Earth observation since it enables synoptic measurements and hence recovering contact-free and large-scale information about the Earth's surface. Among Earth observation instruments, spaceborne synthetic aperture radar is a sensor technology which operates at microwave frequencies and provides high resolution and all-weather imaging of Earth's surface on a global scale, as we can see in this slide. Where it is shown an example of a Cosmos Skymet image covering the area of the Gulf of Naples, which has been acquired in a strip map mode and with a spatial resolution of about 3 meters. And it is a two-dimensional representation of the backscattering properties of the observed scene. Hence, by exploiting multiple SAR images acquired at different times instants and at slight different positions of the satellite, multi-temporal differential interferometric SAR techniques allow to estimate at the wavelength scale displacement of Earth's surface occurred during the time of observation. And hence, for each target which can be monitored at the Earth Earth surface. Also, the historical evolution of the surface deformation can be retrieved, and the deformation time series can be generated. Nowadays, such techniques are successfully exploited for a variety of applications concerning the observation of the Earth's surface and concerning the estimation of the displacement caused by earthquakes, for example, or also the monitoring of unstable areas as those are affected by subsidence or landslides, and so on. So the availability of the recent very high resolution SAR data promoted these monitoring capabilities in urban environments, leading to major steps toward the risk analysis at a single facility level. Thus, it provides a unique tool for an accurate three-dimensional reconstruction and long-term slow displacement monitoring of even single-built structures. As we can see in this example, in the upper left corner, there is a deformation mean velocity map retrieved on the Rome city with a close-up view of the Colosseum, whereas at the bottom of the slide, we have some three-dimensional reconstruction examples of single buildings, for instance, the Maradona Stadium in Naples and the Mirage Hotel and the Cules Fortress in Crete. But we can also monitor such built structures and then have information about the deformation, as we can see in this example, which are relevant to a dam, to a railway line next to the Naples rail train station, and a highway located in the southern part of the Agrigento city. In this case, we have the map. The map is relevant to the estimated thermal dilation component of the bridges. Here is another example which is relevant to another bridges located in Potenza, South Italy, where the red lines stands for the position of the pillars of the bridge, and where the dot located at the center of each span corresponds to an accumulation of the thermal stress, which is also testified by this deformation time series, which has been compared with the local temperatures with an accuracy, and this comparison has an accuracy of about 1 millimeter. So this shows, this highlights the potentialities of these multi-temporal deformation, multi-temporal DINSAR techniques to monitor the single infrastructures. So, as we already know, on the 14th of August in 2018, the Polcevera viaduct, known as Morandi bridges, suffered the collapse of a section of the deck approximately next to the Polcevera River, causing the death of 43 people, and so it was a very tragic event that had a very high resonance in all the main international newspapers. Following the bridge collapse, the Italian Civil Protection Department, together with the Italian Space Agency, asked some Italian research groups highly qualified in synthetic aperture radar interferometry techniques to perform advanced interferometric analysis, exploiting SAR data relevant to the pre-event time interval, in order to capture any possible early displacement associated with structural failures. So here I show you a map relevant to the estimated deformation over the Genova city, whereas in the white square it is evidenced the location of the Morandi bridge. Here I show you some close-up views of the obtained mean deformation velocity map relevant to the processing of two Cosmos-Skymed datasets acquired on both ascending and descending orbit. So the analysis did not reveal any significant displacement. The results have been published on this scientific paper, which you can see at the bottom of the slide. And now I leave the floor to my colleague, Manuela Bonano. Thank you for your attention.
So, good morning to everybody. Now let's move on a few details relevant to the interferometric analysis of the Morandi bridge. First of all, we have isolated the points falling within the deck. And to do this, we apply the threshold on the height of 40 meters in order to isolate the points on the deck from the ground. Those are relevant to the yellow rectangle, as you can see, and we have plotted this height with respect to a horizontal axis, which is the longitudinal section of the bridge. We can see that the points are fall within the deck at a certain constant height. We can see the triangular shape of the first tower and also the tie rod cables. Then we have also highlighted the mean deformation velocity of those points falling in the deck. We can see that we have we have a similarity between ascending and descending orbits, and that no deformation signal relevant to the pre-collapse event are easily detectable. We have in the yellow arrows, we can see that we have two areas where we have a lack of points, maybe due to some secondary effects like vibration effects or strong wind. So this has been done for the northern roadway, but we can move on the next slide where we can see the southern roadway. A similar analysis has been done. We have imposed the same threshold of 40 meters on the height. We have plotted the height with respect to the horizontal axis, the longitudinal section. In this case, we have an important difference between ascending and descending orbits. As we can see, the drastic reduction of points in the descending one. The same mean deformation velocity plot with respect to the horizontal axis, and still we can see no deformation signals relevant to the pre-collapse, and same lack of points in the correspondence of the suspended deck, in particular in the correspondence of the suspended parts of the bridge. So the lessons learned by the Morandi Bridge allowed us to make a large number of test cases by exploiting large quantities of high resolution SAR images, in particular relevant to the Cosmos-SkyMed satellite sensors and constellation, because they provide us wide areas and very important high resolution information relevant to the deformation. Here we have the Napoli case, Bay Area case study that we, as a Center of Competence for Civil Protection Department, we constantly, continuously monitor, but we can see that from the mean deformation velocity map here represented, we have the important Campi Flegrei caldera deformation, but in this case we are not interested on this, but in particular on, please Simone, we are interested on this area where we have detected some very localized deformation events, deformation effects relevant to some buildings and infrastructure. And now we are going to move on the some details on these areas, please. Okay, here we have a zoom-in view relevant to the high-speed connection between the Napoli station, rail station, where we can see the important deformation events continuously, linearly continuously operating starting from 2009. That is the first acquisition date provided by the Cosmos-SkyMed constellation. We can not only visualize the mean deformation velocity mass, but for each single pixel it is possible to detect the temporal behavior of each single pixel, as in this case. Going on for other example, we can see the deformation relevant to the Capo di Chino airport. We can see easily that there are many localized subsidence events in the northern part and also in the southern part of the Capo di Chino airport. If you click, we can see the zoom-in view relevant to on the top, the SP1 connecting the metropolitan area of Napoli. And on the south, we can see the beltway connecting the airport to the city center. In all these cases, it is possible to detect also non-linear deformation events, as in the plots shown in this slide. We can see that, for example, in the northern case, we can see that we have an increase in the deformation rate starting from the middle of 2014. So this was relevant to the Napoli case area, but in the next we will show the example relevant to the Roma analysis that we have done, implemented with always on behalf of the Civil Protection Department, in strong collaboration with the Re-Louis Consortium. So we had available both ascending and descending orbits starting from 2011 to 2019, and we have detected a large number of critical infrastructure that needed to be investigating more in details. As in this case, for example, we have the deformation relevant to the Fiumicino airport on the bottom. In particular, we can see the path of the landing path that is subsiding, and also a corresponding plot of the pixel, the deformation time series of the pixel. On the north, we can see the Grande Raccordo Anulare highway, the strong deformation of more than 1 centimeter per year. But the very recent application is relevant to the integration between Cosmos SkyMed first and second generation. So we are exploiting also the very recent launch of the new constellation, Cosmos SkyMed second generation, that started in 2020-21. And here we have made an integration between the first and second generation over the area of Roma. We can see some example of subsidence relevant to the A90-8091 highway on the bottom, and on the top of a building with some differential displacements. The last slide, we can see the very last example relevant to the preliminary evaluation of the deformation relevant to a single structure. This is another case of a Ponte Morandi in Magliana, Rome, southern Rome, where thanks to the help of consortium Re-Louis and also Roma Tor Vergata University, we have extracted the deformation components vertical, as shown in the slide, of the mean deformation velocity, that is about 2.5 millimeters per year. So just concluding, we can see that these kind of techniques are very helpful to support the activities for the maintenance and of critical infrastructures, because they allow us to detect, investigate over time the deformation affecting single buildings or infrastructure. But it is very important, to my point of view, to have something that is integrated with in situ measurements and with, for example, models for damage assessment from structural engineer, in order to build a system, a roadmap for identifying and preventing critical infrastructure. In this case, the continuous monitoring provided by the new constellation, in particular high resolution constellation, as Cosmos SkyMed, the first and second generation, will allow us to monitor for the next 10 years. So thank you very much.
Thank you very much, Manuel and Simona, for your presentations, and for also mentioning your study, aligning your study with the presentation. It provides valuable information. Maybe just to conclude, because we are close to the end, we received 2 questions in the chat. I think we can combine both. Actually, the main question is, could space satellite data prevent the collapse of the bridge? And maybe Giuseppe also can join this discussion, maybe with 2 lines to reply to those questions.
Please,
by chat.
By chat or by...
Now, with two lines.
Okay.
Giuseppe, you can, I think you were first.
Yes. It's a very good question, of course, and it's a normal question. I would like to say that thanks to the fantastic presentation of Simona and Manuela, we realized that with the satellite, we don't monitor event. We don't have an event detection. We monitor the trends. So connecting this to what I presented with Reticus Safeway, the real question is, if I would have had 100 or 1,000 of bridges to look or to maintain, where should I start? This is the kind of contribution that the satellite help you to realize. And then, like Manuela said, it's a complementary approach.
Exactly.
Firstly, you need historical analysis. You need to realize long-term trends very accurately, and this is possible with satellite.
That changes
absolutely.
a long time.
Then other techniques combined with experience of infrastructure specifically can support specific preventive activities. I don't know, Manuela or Simona, you would complete.
Yes, just to conclude what you are saying, Giuseppe, the example given by the Morandi Bridge allows us to understand that it is not really possible to detect a pre-collapse event. For different reasons, maybe because we don't have the monitoring, because in that day we didn't have any measurements, maybe because of other secondary events like a strong wind, vibration. So it is not really possible to detect the moment, the cause, let me say, of the collapse. What Giuseppe correctly suggested, it is possible to monitor over time infrastructures. For example, if you, as you said, if you have to monitor a large number of infrastructure, it is not really possible, it is not affordable to put a lot of engineers to monitor single structure in a very detailed way. So what it is very important that first satellite measurements provide the backward analysis, because you can go back to time up to 2009 or depends on 2015, depends on the satellite. And then that you can have a very synoptic view of the deformation. So you can follow the trend of the deformation. So you can realize, you can understand if you have to move to some specific buildings or infrastructure. And so only in this case you can ask for engineers, municipalities to make something more in details on the single structure. So this is the very trick for me, and the very important thing of satellite measurements.
Thank you very much, Manuela, Simona, and Giuseppe. I think the discussion is very, very interesting. We could also have, let's say, a number 2 webinar based on this case. Unfortunately, we have to close. I just want to mention because I see a lot of questions coming again, and they are more a bit technical. So we will make available your presentation and your emails in our website, in Areus website and Eurysi website, so the participants can contact you and you can provide them with the answers. I would like to thank all of you who joined the webinar and stayed till the end, the speakers for offering tailor-made presentations, the Genoa municipality for this excellent collaboration. As I said, there will be a follow-up of the workshop in the next days. And if you have more questions, you can also contact us, the Areus Secretariat and Eurysi, of course, Secretariat. Please don't forget that the next webinar is on the 24th of May, the same time. The link is shared in the chat. But you can also find it in our websites if you visit after our websites. So thank you very much, and wish you a nice day.
Okay, thank you.
Bye, everyone.
Thank you.
Bye.
Bye.
Thank you, Margherita. Bye bye.
Bye. Thank you all. Bye.